are Poseidon Engineering: collaboration, sustainability, growth. These are the three core values Poseidon Engineering holds to reform the world's communities. Think about the potential for infrastructure to transform communities, and to transform the world. It's one thing to get the job done. It's another to deliver efficiently, reliably, and sustainably. Our driven and innovative team at Poseidon Engineering is timelessly committed to these values. I am Marielle McMullen, Poseidon Engineering's project manager, as well as water, wastewater, and stormwater engineer.
I am Dana Picardi, water, wastewater, and stormwater engineer.
I am Reese Patterson, the team's civil and structural engineer.
I'm Joseph Armas, construction engineer.
I'm Eric Watkins, construction engineer.
I'm Kyle Domingo, construction engineer.
Poseidon Engineering is thrilled to hold the opportunity to utilize our skills and expertise within the UC San Diego Thurgood Marshall Undergrad Housing Development Project. Poseidon Engineering focuses on civil, environmental, and construction engineering and has provided services throughout the entirety of Southern California. Demand for new student housing is becoming a key driver in the expansion of the UCSD housing supply that is currently unable to coincide with the increasing student population. The UCSD Thurgood Marshall project will provide approximately 2,000 new student beds on campus, expanding the supply of student housing as well as upgrading the facilities and infrastructure of the existing buildings. Poseidon Engineering will specialize in demolition, water resources, water treatment, site logistics, contractors' estimate and scheduling, as well as foundation and shell design for the main buildings.
Poseidon Engineering will utilize a conscious design approach to effectively achieve project goals. We prioritize high-quality design and construction, sustainability implementation, staying on time and within budget, collaborative teamwork, and commitment to safety.
The following chart represents the submittal and project milestone schedule, which is an overview of the design phases that took place after being awarded the project on January 21, 2022. From the initiation of the preliminary design and during design development, the construction team began developing the construction program with the end in mind. Furthermore, the construction team began producing two main deliverables during schematic design and design development phases. First, the preliminary cost estimate, and second, the preliminary construction schedule. The two deliverables are based on project definition and are adjusted to match any design changes made in creating the final building design. Once design is fully developed and approved by UCSD, contract notice to proceed and job site mobilization commences, which is scheduled to start May 9, 2022, as illustrated in the schedule here. Within the schedule, I'd like to highlight the new construction phasing that occurs after about a month of site work and selective demoing. Foundation scope of work for all four buildings is expected to be completed within 4 months. Once foundations phase is entirely completed, the scope of work for structure and shell commences with Building 1. Between Buildings 1 through 4, activities are identical, and the commencement of the buildings to follow are arranged with different start dates. With that said, the completion of Building 1 is expected to be completed January 9 of 2023, and the following buildings are completed a little bit over a month from each succeeding building completion. Thus, the scope of work, foundation and shell is expected to be completed early May of 2023.
Our construction team established a plan that was organized to most efficiently lay out the site during the construction process. As seen in the overhead view of the site, the truck haul routes run along the north side of the site on Voyant Drive, where they will turn left and enter through the west gate. As seen in the northwest portion of the site, the OAC parking along with the contractor's trailer is located by the entry gate. For scheduled material deliveries, the trucks will enter and proceed towards the exit, where the material laydown area will be located. These routes are designed to make sure that deliveries are timely and efficient to stay on schedule. Surrounding the site boundary, there is fencing, which is depicted by the orange lines along with the SWIP BMPs that line the fences, and this is shown by the dark blue dashed line. Lastly, the yellow boxes that are shown between the two construction areas are the personnel gates for team members to enter and exit the construction site from.
As part of our pre-con site logistics plan, it is important to take into consideration the SWIP or Stormwater Pollution Prevention Plan layouts prior to the start of digging and rough grading. Firstly, the site will be lined with silt fencing, as marked in green, to prevent water runoff into the surrounding streets, Voigt Lane and Hopkins Lane, as well as the surrounding student living areas. We will add stormwater support with fiber rolls displayed in yellow, especially lined against the main roadways. Storm drain inlet protection will be lined with the corresponding drain locations in the current storm drain system to prevent drain contamination. Planning ahead for when grading permits are obtained from the city and rough grading is able to commence, we have provided an erosion control plan to help prevent soil erosion. Geotextiles displayed in purple will be laid on top of formerly shrubbed areas post-clearing and grubbing. This will add extra protection for newly roughed soil from rain and other erosion-causing forces. Soil roughening/hardening trails displayed in green will be created to assist and provide extra traction to vehicles and personnel moving about the site.
As the civil and structural engineer for this project, I was responsible for designing the floor plan, foundation, and shell designs for one of 4 newly constructed residence buildings. Each residence building is expected to house 500 students. The redesigned floor plan of the housing units will be 13,104 square feet, composed of 2 to 3 person bedrooms with 60 to 70 students per floor, along with 2 communal-style bathrooms, 2 stairwells, 2 elevator units, and a large community room. The shell design proposed consists of 7 identical floors of the designed floor plan layout with a 15-foot span between floors, utilizing 9-foot high ceilings with 6 feet allowed for mechanical systems, floor framing, and floor deck. A geotechnical study completed through GeoCon Incorporated was obtained, providing details and recommendations based upon soil studies and reports completed. The soil studied consisted of 3 general soil types consisting of topsoil, lignocrystal formation, and stadium conglomerate, with the most predominant bottom layers proving to possess adequate support characteristics for structures. These studies further determined a continuous strip footing foundation with at least 12 inches of width and at least 18 inches of depth were recommended. The structural design method utilized is a load and resistance factor method following the American Concrete Institute and the American Society for Testing and Materials standards and recommendations. The foundation layout consists of a 72-foot by 182-foot structural layout. Per geotechnical data, the maximum bearing capacity that the foundation can uphold is 10,000 pounds per square feet, with a current allowable bearing capacity of 4,000 pounds per square feet, with an additional 1/3 for an increase in dead and live loads. A concrete slab-on-grade design method will be utilized, requiring a thickness of at least 4 inches and reinforced with No. 3 steel bars. Beam and columns utilized within the structure and foundation will utilize a steel-reinforced concrete design approach.
The environmental engineers developed sustainable and adequate water, wastewater, and stormwater systems for the new residence building.
In preliminary studies, the existing site's location of pipes and inlets were obtained from UCSD's main campus BMP treatment control. The Thurgood Marshall College currently has 4 existing BMPs on site. However, there are currently none located at the existing Lower Marshall apartments. It was found that the closest BMP to the existing Lower Thurgood Marshall apartment is located near Goody's Market, about 150 feet from the site. Drainage studies and a stormwater quality management plan were conducted in order to ensure that stormwater is adequately managed, treated, stored, and reused. The new proposed site includes implementation of 4 new BMPs, storm drains, 5 pipes totaling 1,095 feet in length, and a storage basin within site boundaries in order to further meet existing goals of stormwater management and treatment. An approved stormwater quality management plan has been developed, defining the controls and handling of stormwater runoff from the completed site. Treated stormwater will be stored and sustainably reused for irrigation of native and climate-appropriate landscaping, conserving potable water and maintaining the hydrologic balance. This reuse system will earn credits complying to LEED for neighborhood development pilot, satisfying the credit to minimize water use in buildings and for landscape irrigation by installing landscaping that does not require permanent irrigation systems. The domestic water and sewage systems were both effectively designed in order to adequately support the housing population. Wastewater flows were computed to be 44,000 gallons per day. Pipes were sized and upscaled for a factor of safety and in the case of potential capacity issues, and will be uniformly composed of PVC. In the unlikely case that there are capacity issues in terms of the proposed sewage system, the UC San Diego Sewer System Management Plan is designed to prevent and reduce sanitary sewer overflows, and routine maintenance and inspections will be conducted regularly. The domestic water system will comply with the UCSD Disinfection of Potable Water Systems Guide, and Poseidon Engineering has consulted Trident Technologies to perform a commercial disinfection. An average daily demand of 330,000 gallons per day and a peak demand of 792,000 gallons per day will be required for the entire building. Fire flow demands were calculated to be 8,000 gallons per minute for the building, resulting in the configuration of 5 fire hydrants with a maximum capacity of 1,500 GPM, and will be implemented on site 250 feet away from the buildings, complying with National Fire Protection Association guidelines.
Poseidon Engineering is committed to and thrilled to fulfill UCSD's long-range development plan to adequately accommodate the student population in the Thurgood Marshall Housing Project. Our driven, innovative, and passionate team will ensure that UCSD's housing and academic goals are met. We thank you for choosing Poseidon Engineering.